So when you look, we're on page 17, and we're gonna write the equation of this thing. All right. Does anybody have any idea, looking at what has been drawn for you, the picture's been drawn, does anybody have any idea where we might start? Well, think about how you graphed. What was the first thing you did yesterday when we were graphing those?
Draw your point.
What? We plotted our points, right? And where did those points come from?
The opposite.
They came the opposite of the parentheses. So guys, if you see a dot here at -2, 0, what does that mean you had to have had in your equation? X plus 2. Yeah. And I got one here, so I had to have had x minus 1. And I have one here, so I had to have had x minus 3. Would everybody agree with that? Okay, now I'm going to look at that picture carefully. Here, I'm going right through, which tells me what? If I'm going right through that point, then I don't have a power on that parentheses, right? But what's happening here? There I'm bouncing, which means that parentheses has to have a squared. And then that one doesn't. Right? Now, I am done, except for one thing. There's one thing missing in this problem, and it is this number out here in front. Now, I'm calling it A, you can call it N, you can call it whatever you want. But think about yesterday. Weren't there problems yesterday that had like a -2 or something out there in front?
Yeah.
I have no idea. I gotta figure it out. Look at that. Is there something in that problem that I haven't used yet?
2.
This guy up here, I haven't done anything with him yet. This is an X and this is a Y. So guess what I'm gonna do? I'm gonna come down here to this equation and I'm gonna put 2 right here. And I'm gonna put 0 in for X. Sorry about that, who knows why that does that. 0 in for all the X's. And I'm gonna figure out what that is. So 2 equals A times, all right, 0 plus 2 is
2.
0 minus 1 is -1, but we are squaring that, so that's just 1. And 0 minus 3 is -3. So 2 equals, all right, let's multiply all these together. What are those? They're all multiplied. This is a 100% multiplication problem. -6a. Which means A is -2/6 or -1/3. Which means this is the answer to the question. There's a lot of work involved with getting that 1/3, but 1/3, -1/3 is not the answer. The answer is the whole equation. Does it make sense that that would be a negative? Look at your picture.
Yeah, it's going down.
It's upside down, right? Right. So that is definitely that. All right, let's try the next one. Remember that when you start building your equation with the factors, remember that only dots get factors and only factors get dots. Remember that? So the dots are, and I'm talking about dots on the x-axis. I have one at -4, so that means I'll have what? X plus 4. And then I have one at -2, so that will be x plus 2. And then I have one at 3, 0, so that will be x minus 3. Do any of those have powers on them? Laz is shaking his head. Why is he shaking his head?
They all go
Because
straight through.
every one of them, I just keep going right through, right? You don't see any of this in this picture, in picture B, right? So no powers. So we're done, except for this guy. Let's figure out what he is. So what do? We plug in the other point. Remember, these come from the x-axis. That other point, which is 0, -3, means y is -3 and x is 0. Remember, you're multiplying all the way across. So what is that? -24? I got +1/8. Everybody else get that?
I do.
Good. Does that make sense? Look at your picture. You just told me that my number out in front was a positive. Does that make sense in terms of your picture? Yeah, because it's starting down and going up. That's the way they go. Right? You guys that need to go to the assembly of early dismissal, you need to go ahead and go.
Said football players can go.
That is not a football player. No, you are not leaving at 9 o'clock for your game. Okay. All right, let's try one more. Let's try C. This one can be a little bit tricky if you're not paying close attention. How many factors am I gonna have in problem C? Actually, I'm going to have 3. How do I know I'm going to have 3 factors? Because there's 3 x-intercepts. There's 3 dots on the x-axis. All right? So my first one's going to be x plus 2. What am I going to do with that second one? It's just a plain x. Very good. Now, if that bothers you, could you make that x minus 0? Sure, if that makes more sense to you. I prefer just to have a plain x, so I'm just going to have a plain x. But if you need a number in there, it would be a 0, x minus 0. And then I'll have an x minus 3. All right. Are there any powers in there? Where are the powers going to be?
The first one,
The first one has a squared. Everybody look at your picture. Why does the first one have a squared? Bounces.
So it's the second one.
The second one also has a squared because it is bouncing. Does the third one have a squared? No, because it's going straight through. You are done, except for that number. We do not know what that number is. How do we find that number? Plug in the other random point, which is, in this case, 2, 2. So 2 goes into y. A 2 goes in for all of the x's. And then we figure out each parentheses, so 2 plus 2 is 4, and 4 squared is
Big old
16.
number.
2 squared is 4, and 2 minus 3 is -1. Multiply, all multiply. So, -64. So if I reduce that, I get -1 over 32. There's your answer. Anybody have a question about that? Easy enough? Well, D is exactly the same thing, only there's no picture. If it helps you to draw a picture, absolutely you can. Remember, the word zeros means those are your dots. So this guy has dots here. So what does that tell me about my equation? Zeros are x-intercepts, what we have been calling dots. What do I know about my equation? Y equals what?
X plus
X plus 1,
X minus 2.
x minus 2,
X minus 4.
x minus 4. Without a picture, I have no idea if I'm bouncing or not, so I'm not gonna mess with it. If I don't have a picture in front of me, I don't know. So, I'm just gonna leave it like that. The only thing that's missing is that. I can figure that out because notice they gave me another random point. So what will I do? Plug in 10 for y
And then
and
1.
1 for all the x's. Okay, you guys do this one. You figure out that a. Anybody got it? A?
5/3.
5/3?
Yeah.
Alright, I heard 2 of those. Let's double check that. So that's 1 plus 1 is 2. -1. -3. Six. Oh, I think you're right. Good job. Good job. There's your equation. Alright, so 2.3 homework is due on Tuesday. And we are gonna start 2.4 right now. In order to sketch this problem, we need to have it factored. So this is not new, you have done this before. How do we factor something that looks like this?
2 parentheses.
Yeah, we group it, that's exactly right. So what am I gonna take, Mr. Ayers, what am I gonna take out of these first two?
X squared.
X squared. And that will leave me with,
X, 4, or negative 4.
minus 4. Now, this one's a little bit tricky. Negative 1. Negative 1 is what I'm gonna take out, and if I take out a negative 1, I will be left with X minus 4. Remember, if you take out a negative, you change the signs. Now, do we have a match? Yep. So we write it down, and then we put everything else in another parentheses. And then, pay attention, what do you notice about x squared minus 1? X plus 1, x minus 1. Guys, we did this back in chapter 1. So here's your equation. Now it is factored. So now, hopefully, you can graph it. Just like yesterday. How do we start? We're gonna graph this. What do I do first? Put my points on. So 4. And some of you are not in the habit of labeling. Let's get in that habit. Remember, when you are graphing, you need to pay attention to how many x's you have. Now, in this particular problem, we knew right from the beginning, how many x's do we have? 3, right? You can see it from the factors too, but we had it all multiplied out. We have 3. Where does x cubed start? Any x cubed is going to start down here. So here we go. Now, I said any x cubed is going to start down. That's kind of not true. X cubed will start down as long as that is positive, right? Now, do I have any squared or anything on these guys? So what does that mean? That means I'm just going to connect the dots, no bouncing, just connect the dots. So here I go. Connect, connect. Here we go. All right, you okay with that? All right, try the next one, problem B. Start by factoring it. I want you to try to factor it by yourself. So I'm not gonna do it for you right now. You're gonna do it yourself. You're gonna factor it. Doing the grouping thing that we just practiced. And if you think you have a factor going, we sketch it. All right, somebody give me some factoring ideas. What'd you do here? Took out an x squared, and that left you with x plus 3. And then what did you take out? Negative 4, and that left you with x plus 3 because 12 divided by 4 is 3, right? So far, so good? Now, these gotta match. So I write down that. And then left over is x squared minus 4, which you have to recognize factors how?
X
Plus 2 minus 2. And then we're done?
Nope.
We're ready to sketch? So my dots, remember the dots go with the opposite. So the dots are -3, -2, and 2. Just exactly like the last one, this is an x cubed.
Yep.
And x cubes are gonna start down here.
Yep.
And just exactly like the last one, there are no exponents. So that means go through and connect, go through and connect. Got it? All right, the next one is exactly the same, except there's this 2 in there. What do you think we're gonna do with that 2?
Take it out.
We're gonna take it out. We're gonna take it out. Now, we can't like just get rid of it totally, but we're going to factor it out. So, we're gonna have 2 x cubed minus x squared minus 4x plus 4. Take a look at that. Make sure that makes sense to you. You see what I did? I don't want that 2 in there. But it is part of the problem, so I have to keep it, but I'm gonna separate it from all of this. Now, can I factor this?
Yeah.
Yep, I can factor that. I'm gonna just factor this right now. How would I factor this? Take out an x squared, and that will leave me with what if I take out an x squared? X minus 1. What am I gonna take out here? -4, very good. I know we talked about this back in chapter 1, but if this, so you're gonna factor these 2 terms, if that's a negative, take out the negative. Always pull out the negative. And then that will change that to a minus. And then we have our common term. And x squared minus 4. And what do we know about x squared minus 4? And then remember that 2 that I factored out and kind of have been ignoring? He's part of the problem. Now, do I need to worry about that 2 though when I am graphing? The only time I would have to worry about him is if he were negative. Then I'd have to pay attention to it, right? But since he's a positive 2, he's just there. That's that A number that we were finding earlier. All right, so let's sketch it. Everybody okay with your x-axis? Now, he's a positive 2. Where do I start? Whoa, whoa, whoa. It's x cubed.
On the bottom.
X cubed starts down. Connect, connect, connect. There you go. So far, so good. Because we're about ready to take a giant leap forward. Take a look at problem 4. Looks like the same exact kind of problem. Anybody notice anything about problem 4? Well, what do you want to do here?
There's a 2
Doesn't it look just like the ones we've been doing? And so we'll factor by grouping. Is that bothersome to anyone? I can take out an x squared from the first 2. I can take out a -1 from the second 2, but what didn't happen? I don't get a match. And if you don't get a match, you can't do this process. Factoring by grouping depends on getting a common factor here, and we didn't get it. What does that mean? Oh no, it's factorable, but just not by grouping. So here is what we do. We have to find the factors of this thing, and there will be 3 of them. Would you agree with that? There'll be 3 of them, because this is an x cubed problem. And factors are numbers that when you divide them in, you get no remainder. Right, just process that for a second. If I say 5 is a factor of 10, you would agree with me, because 10 divided by 5 goes in evenly. Is 3 a factor of 10? No, because when you try to do that division, you get a remainder. So here's what you get to do. You get to start guessing numbers, dividing them in, and hoping like heck you get a remainder of 0. Now, if I'm you, and my teacher's up here saying, start guessing numbers, I'm getting a little nervous. How many numbers are there?
Infinite.
A lot. So could this be a very long process? Yes. There is no way to eliminate the guessing totally. You're going to have to guess. But there is a way to narrow down your guesses. All right? So in a moment, we're going to do a division. Okay? We're going to narrow down the numbers that we're guessing though. Okay? So I'm just going to have somebody randomly guess a number. 3. Here's how we're going to divide. You may have never done it. Did you guys do synthetic division last year?
Yeah.
Oh, you did? Oh, good. Okay. So somebody guessed 3. Did you do this too?
Oh, I remember this, yeah.
So somebody guessed 3. So that's why there's a 3 in that box. That's the number I guessed. There's no magic there. Somebody guessed it. Now write down all of these coefficients. So see what I did? I wrote a 1, a 2, a -5, and a -6. See that? Now, I left some space in here because I'm going to be writing some numbers in there. Drop this first 1, whatever that number is. It might not be a 1. Drop that first number straight down. Then we're going to multiply 3 times 1 and put the answer here. And then we're going to add these. And then we're going to multiply 3 times 5 and put the answer here. And we're going to add these. Remember this from last year?
Yeah.
And then we're going to multiply 3 times 10. Put the answer here and add. Now, does anybody remember what all this means? Now, I'm done, the process is done. Does anybody remember what this all stands for now? This stands for, remember how the original was x cubed? After you do a division, it becomes an x squared. And then this becomes a 5x. This is a 10. What's that? That's the remainder. So you guessed the number 3, and it is not right. It's a good guess. Actually, it's a really good guess. We're gonna talk about that why in a minute. It's a really good guess, but it didn't work because I'm trying to find factors. And what happens if you have a factor? It divides in, but that number should be a 0. Because a factor means no remainder. So I don't have one. Alright? So guess what you get to do? Guess another number. Here is the pool of numbers you guess from. They are called the possible rational roots. I'm going to refer to them as the PRRs, possible rational roots. Possible. These are your guesses. They are factors of the last number over factors of the first number. So this is, when I do the division, this is my last number, and this is my first number. Now, what are the factors of 6?
2, 3.
2 and 3, and 6 and 1. So for this problem, those would be the guesses. Notice, is 3 in there? That's why it was a great guess. But it didn't work, so I'll have to guess another one, and we'll pick up here next time. All right, we are sitting. Listen carefully because you gotta be in the right spot. You know where the fan sits? We are in the top 2 rows of the band area. Phones are in the caddy. We are in uniform. We have our lanyards on. We're heading to the top 2 rows where the band sits. Oh, and I got to turn the video off. Otherwise, we'd have a nice long